Hello YouTube. This will be our part where we will actually show visually how this game of life actually works, and we will also try to integrate genetic algorithm to find the smallest amount of population that will cover the entire grid. Yes, and for that we also have to remove the condition where we actually kill the cell based on overpopulation. Okay, so we are actually removing that condition, otherwise it will actually just going blank for um, after just few generations. Okay, so some friends are actually playing. So uh, in the game of life, this will be the main class which will have all the grades, cells and population, and will have different function for creating population at the start, then creating a new generation based on survive and newborn, and differ. We are actually using it to calculate the difference between current and next generation, so that we can also figure out what is the fitness of this. We will actually use these numbers to get the fitness. And survives newborn function, same as the previous video, and the condition to get the surrounding cells which are alive, get the populations, and start population, return differ. Yeah, this is the fitness. Okay, sorry, this differs is actually meant to find if those are previous and new generation cells are actually same or not. Okay, because there were some cases and it just stuck in a loop, so we had to do some different things, and you will also see there were some patterns which just become one, then we just go forth and back. Okay, like some three in a row vertically or horizontally, so they will just make a cross that will actually cause some problems. Mutate. Okay, random. I fixed the mutation date here. Okay, and this total population, how many of them are alive and not, these different functions which are overall used for the fitness part. Okay, so now this one population. Okay, game of life population. So this is the class which will handle the entire population and calculates its probability, fitness and cumulative probability. Okay, create new generations, calculate these things and do the crossover. Okay, based on some conditions. Here we are also getting if two of the if parent 1 and parent 2 of same cell. Okay, like two different population has the same cell as active or alive, you can say, and again the 50% chance again, so that it is alive. We are actually just making it really less probable that a cell will be alive. Okay, otherwise if it we leave it as it is, then a lot of them will be alive, and the generation or simulation won't go to about 100 or more. It will just end in between. Okay, that is the reason. Select parent, print all and print fit. We are actually just printing the fitness, probability and cumulative. It is just the debugging system, we don't really need this one, but still this will be useful to know the what is the last population that was most fit. Okay, this is the kind of J component part where I'm using to some graphics to show it. Okay, all of these are just to create new things and redraw all the things. Okay, so paint component will draw everything, create the grid, uh, then create a rectangle for each of the cells, and if it is alive then we will use fill rect and fill that cell with blue color. Otherwise it will be always red. Okay, I'm not even filling it, so it is actually the border. Okay, now this is it. Okay, yeah, this is just some cell movement so that we can fill the color. Okay, now this part in sliding the entire window, display window, and running the generation, all those populations, I mean all these generations, and how many populations we are actually going for. Game of life. 120. Yeah, this does not really follow that kind of thing, that kind of pattern for object oriented programming or polymorphism or overriding. This is just simple old code. Okay, so let's run this one. Okay, you see at the start it start from some things. Yeah, these are the actually things, vertical 3 and horizontal 3, which actually go in loop. So you have to just end it after some generation, which are some arbitrary loop for survival and newborn. Okay, so you are seeing that it generally starts from 5 or 6. Best I could get was 4, which starts with 4 different cells and later cover all of this, you see. And yeah, it's not what do I say, all the populations won't actually survive till the end of the simulation. Some of them just die out, or some mutation will cause any one of them to die. And these are about how many, 120 different simulations of game of life. Okay, and you see all of them are dying out because that of that probability, which actually causes it to only some of them to be alive. And if they are actually far away, like in if different corners, then they won't suffice any of the conditions which make it alive, and they will die out. Okay, this is the result. Let's see what happens at the end. And yeah, I'm also printing it. Okay, it's only up to 23 generation. We will wait for 50. Yeah, 50 is the end. Then okay, where is it? Yeah, 50. We will wait till 50. Okay, you can see this one. This is the actually starting population. Okay, only some of the cells, around 4 cells, are alive, but the end of it, you will see most of them are alive. I think 1 2 3 4 5 6 7 8 9 10 12 13. Okay, about 90% of them are alive. So using genetic algorithm, we found a solution of a game of life. I mean, not exactly a optimal solution, but it's still feasible. And we are able to actually get some population which will work as we want. Okay, so thank you.